and Research Department of Computer Science and Computer Applications, VICAS. In this session, I am going to explain about transactions. Now, what is this? Is an important topic in relational database management system. Now, what is this transaction called? In the day-to-day life, we perform many transactions such as we withdraw amount from our account, or we deposit amount in our account, or we transfer amount from one account to another account. Salary is credited to the account. These are all the examples of transactions. So here we are in RDBMS, we are going to learn in detail about the transaction concepts and the properties of transactions. So what is a transaction? So this is a collection of operations that form a logical unit of work is called a transaction. So logical unit of work means amount transfer from account A to account B. This is a logical unit of work. Withdraw 1,000 rupees from account A. This is a logical unit of work. Deposit amount in account A. This is a logical unit of work. But this work involves n number of operations. For example, in this given example, there is a transaction in which we transfer amount 50 from account A to account B. So this is a transaction. It is a single unit of work. But this involves the operations like first we are reading account A, then we are we subtract 50 rupees from account A and write this value into database. Now we are reading B from the database, adding 50 to the balance B. Now we are writing back to the database the B value. Okay, so here there are two read operations and two write operations. Okay, so the collection of operations that form a single logical unit of work is called a transaction. Okay, so in the transaction, should be executed fully, complete. Transaction should be executed fully. Okay, but in the middle, if there comes some hardware failures or system crashes, then our money is lost. For example, we have debited amount 50 rupees from account A and we return the amount A to the database, but we not yet have credited amount in account B. That means the money is lost and the database exists in inconsistent state. Okay, this should not happen. This should be avoided. Okay, for that only so many rules and some properties are introduced in that is the properties that the database must maintain. Okay, during the transaction are introduced. So here the atomicity requirement. So there are mainly there are four properties of the transaction, like atomicity, consistency, isolation, durability. Now I am going to explain these four properties. Atomicity. What is the atomicity property? So first slide we have learned about what is a transaction. Now what is this atomicity requirement? Suppose in our day-to-day life we often do the mobile recharge. That time what happens, we from our account we transfer amount to the that mobile particular opposite party. For example, we are doing the recharge of rupees 500. We transfer amount 500 to that particular opposite party. So that sometimes what happens, from our account the amount gets debited, but the amount will not be credited in the opposite party due to some network failure. So the recharge will not be successful. Okay, so what happens, the money is lost. That is, the first half is executed successfully, the second half of the transaction is not yet executed. So the failure in the middle. So our amount is lost and the database remains in inconsistent state. Okay, this should not happen. So either the entire transaction should be executed and completed, or if it fails in the middle, it should return back to the initial state itself. It should roll back to the initial state, the starting state. Okay, so that is atomicity. So this atomicity is due to this atomicity property only, we are able to sometimes, even though our money is gone, after 2 hours our money is returned back to our account. That is due to this atomicity property. This is implemented in our database. So if the database fails in the middle, then what happens? It is rolled back. Okay, whatever happens, the database updations happened, all are undone, and it is rolled back to the initial state. Okay, so this is the atomicity requirement. So atomicity requirement needs the database should, this transaction should be entirely completed, or none should be executed, or if it is executed and failed in the middle, it should return back to the initial state itself. So next is durability requirement. Durability is, it is suppose the transaction has been executed successfully. Okay, we have made all updations in the database. Now these updations should remain persistent, should remain permanently in spite of failures also. Okay, so this property is called durability. So even though we switch off the system and go, the database should save the data permanently. That is the durability requirement. Next is consistency requirement. Consistency is, take this example, during the fund transfer from account A to account B. So what happens? First we have to read the account A. Look at this example. First we have to, suppose we are going to transfer amount 50 rupees from account A to account B. Let us say account A has the initial balance of 1000 rupees and account B has the initial amount of 2000 rupees. So total amount is 1000 plus 2000 is 3000. Now we are going to transfer rupees 50 from account A to account B. So what happens? First we have to read A. Read A means 1000. Read 1000. Now A equal to 1000 minus 50. So what 1000 minus 50, we get 950. Now this 950 amount we are writing to the database. Now again read B. So read B account. Now this 50 rupees we have to add to account B. So what happens? Now the B has 2000 rupees. 2000 plus 50 is 2050. So 2050 is written into the database. So now the 950 plus 2050. So we get the answer is 3000. So before account transfer also the amount was 3000. After account transfer also the amount was 3000. Okay, so the system remains in inconsistent state. Suppose in the middle, if some failure